Okay, now I'm going to work on number 4b from the review. And they want us to find the inverse of this function, f of x equals x squared minus 6. They don't give a domain restriction to this problem, so you have to take it upon yourself to do it. And here's why. If you think about what this function looks like, it's a parabola. Parabola shifted down 6. X squared minus 6 is a parabola shifted down 6 places. So, if you tried to find the inverse of this parabola, let's think how it would look. It's going to be a reflection over the line y equals x. That's how we find an inverse graphically. So it basically flips like this. A little bit hard to see there, but if you flipped this, it would end up looking somewhat like that. All right? And that wouldn't be a function, because it now wouldn't pass the vertical line test. The moral of the story is you can't find the inverse of an original function if it doesn't pass what's called the horizontal line test. If you pass a horizontal line anywhere through this graph and it hits the graph more than once, it fails the horizontal line test. So we have to do what's called a domain restriction and only look at the right side of the graph, let's say. We're only going to look at this graph or this function when x is greater than or equal to 0. That basically eliminates this whole part of the graph from consideration. We can definitely now find the inverse of this because it passes the horizontal line test when you just look at the right side. So what we're going to do is we're going to go ahead and replace f of x with y, switch x and y, add 6 to both sides, and take the square root. So we find that the inverse is the square root of x plus 6. If you remember that from our studies in chapter 4, that would be a radical function shifted to the left 6. 1, 2, 3, 4, 5, 6. And it would be something like this. So imagine where that highlighted graph will intersect that radical. Probably right here, definitely right here on the line y equals x. If we look at the line of symmetry, the line y equals x, my graph isn't drawn perfectly, but not too bad. You can see that as this is moving up and to the right, this is moving up and to the left, and they're going to intersect right there, making it look like the perfect inverse. So this would be considered the inverse of f of x. Sorry, f with a little negative 1 is the square root of x plus 6. Okay? F inverse is the square root of x plus 6. Next, we have the function f of x equals 7 minus 1/2 x. This comes from problems 6, 7, and 8. F of x equals 7 minus 1/2 x. Many students get confused by problems like this because of the order in which it's drawn, or in which it's written, where you have the 7 minus 1/2 x. Perhaps it'll be a little easier to understand if you rearrange the order here. This is similar, or exactly the same as, negative 1/2 x plus 7. See, the 7 is positive and the 1/2 x is negative. Don't get confused by that when you go ahead and switch x and y to find your inverse. All right? Now that we have the x and y switched, you can see that we're going to subtract 7 from both sides and then multiply both sides by negative 2. Multiply both sides by negative 2. If you're wondering why I'm doing that, when you multiply by negative 2 times negative 1/2 ends up being 1y, and that's what we want. We want to get y by itself. An alternative there is to divide both sides by negative 1/2. I just don't like dividing by fractions. I was taught not to do that way. I learned from my good friend Mr. Dorito by the reciprocal, not divide by a fraction. That was always a no-no back in my high school days. So the inverse here is negative 2 times x minus 7. So let's think about that. The inverse of taking x times negative 1/2 and adding 7 is subtracting 7 and multiplying by negative 2. So whatever you start with in the original function, like when you do number 6, they wanted you to find f of 4. So in the original problem, number 6, if I plug 4 into this function, I get half of 4, which is 2. Make it negative, so we have negative 2 plus 7, I get 5. Let's think about what I'll get in number 7 when they want me to find f inverse of 5. Keep in mind, in number 6, when 4 was the input, 5 was the output. What do you think is going to happen when we put 5, the old output, as the new input in the inverse? My prediction is we're going to get the old input 4. Remember how x and y trade places when you find the inverse? Well, that's what happens. The old input becomes the new output. We should get 4. Let's check. Plug in 5 in your head. 5 minus 7, negative 2. Negative 2 times negative 2 is 4. Finally, in number 8, they want you to find f inverse of 4. We're going to plug 4 into the inverse. 4 minus 7 is negative 3. Negative 3 times negative 2 is 6. So there are your answers for 6, 7, and 8. Finally, we have 12c, and it's 7 to the x minus 2 equals 49 to the x power. One way to do 12c is to recall the way that we did this problem way back earlier in chapter 5. We rewrote 49 as 7 squared, and we got 7 squared to the x. Then we would multiply the 2 and x to get 7 to the 2x power. Then we thought, oh, great, because now my bases match. And when my bases match, I can basically ignore them. So we get x minus 2 equals 2x. Take away x both sides. Negative 2 equals 2. 1x is 1x. X equals negative 2. Done. Method 2. I like this one. Interesting way of looking at it. Use logarithms. We logs for an anytime component. One thing we talked about was rewrite it as a log. Base 7, and then the 49 to the x, and the exponent, x minus 2, equation. They flop 40 there. The exponent is always on your final log. Very common made last week when we started talking. At this point, we now have log properties. I have a logarithm with an exponent in it. The exponent can come out of there and become x times the log of 49 base 7. If the light bulb went off, that's good. If it didn't, it should be about to, because the log of 49 base 7 is 2. Remember, the log of 49 base 7 is asking you, what exponent turns 7 into 49? Answer, 2. So we have 2 times x equals x minus 2. We're right back where we were in the previous method. Take away x from both sides, you get x equals negative 2. That concludes the review for today. If you have any other questions, let me know in class tomorrow, 5.1 to 5.3, and then some word problems from 5.8. Have a good night.